All right, guys, let's do some programming using object-oriented design, some abstract classes, and some inheritance. Maybe get a little chance to show off some polymorphism from the presentation from yesterday. All right, so I have this class called geometry right here that I'm going to be utilizing. It has my main. Out here, I have three classes: parallelogram, square, and rectangle. And if you remember from geometry, a rectangle is really a type of a parallelogram, and a square is really a type of a rectangle. So we can use inheritance across this right here. So in my parallelogram class, if you look, I actually defined it as abstract. And I didn't have to, but I'm going to show you why I did here in a second. One, mostly for demo purposes. So in a parallelogram, you have four sides, right? But side one and its opposite side are equal, and side two and its opposite side are equal. So all I have to do is set side 1 and set side 2. So in my default constructor, I set side 1 to 1, and I set side 2 to 1, which actually makes this thing into a square anyway, but I'm not going to get into those rules right now. And then if they call the parallelogram constructor and they pass in two sides to me, then I'll go ahead and set the sides for them. And then I made a method called getPerimeter, which returns 2 times side 1 plus 2 times side 2. And then down here, I went ahead and made an abstract one for get area because get area itself is different for a parallelogram than it is for a rectangle. For a parallelogram, you need your base and your height. We don't actually have the height here right now. So we would need to know some other information. So I'm not really ready to get into that. So I just went ahead and defined this as an abstract method that has to be done. All right, so now I'm going to come over to rectangle here. And in rectangle, then, if I want to use the parallelogram class, then I'm just going to go ahead and say extends parallelogram. All right, there you go. And right away it throws up an error at me, and if I mouse over that, it tells me that I must implement the inherited abstract method get area. So I have not inherited get area. What I did is I actually commented it out down here. So remember, with an abstract, it tells you that you must define it inside. If I'm inheriting this, if I'm inheriting parallelogram, then I better define a get area method. So there it is. I'm going to return my base times my height is all the get area method is going to do. So let's come back in here and let's talk a little about some of the stuff here. So I have a default constructor. So right now, by default, I've been running my default constructor is just simply setting. I don't need my base and height here either. I'm sorry, I can get rid of this. I don't need that. That's duplicate code. All right. In here in my rectangle, I can simply say super open close parentheses, and that will automatically go and run the super constructor and set my base and height up inside my parallelogram to 1 and 1. And then in my rectangle here, they're going to pass me the base and height. So what do I want to do? I want to call the super constructor for that one and pass base and height to it. And it will it'll set side 1, side 2 to whatever my value of B and H are. All right. Now, in my rectangle, so remember my side 1 is really just, and my side 2 are actually base and height really, because it's a rectangle. And so now I'm going to do my set base command here, right? So I want to be able to actually set my side 1 up here inside my parallelogram. And I do not have a method for setting side 1 up here. So I can go ahead and simply say public static, sorry, not static, sorry, public void set, go ahead and say set side 1, and we're going to make that our base, and we're going to do int s1, and we'll go ahead and say side 1 equals s1, and that's going to be int of set side 1, and I'm going to go ahead and copy this one, because we're going to do the same thing for side 2, and we're going to come down here and set side 2 now, and I'm going to set that to S2, right, because I'm going to call this side 2, and I'm going to pass in S2 to it, and I could have just called it S. All right, so now I'm setting side 1 and side 2 in here, oh, I called it S right there, my bad, sorry, side 2, and that should work for me now. So these are public methods. So down here, In rectangle, when I call set base, there is not a super for this one, right? There's not I can't just say super and whatever else, but what I can do is I can call the super class. And what was my super class's method called? It was called set side one, and it needs a value to be passed into it, and what are we passing into it? B. And that's now going to set my side one. And I can simply down here say super dot set side two, and then I just got to pass in a parameter to it. I'm going to pass in age, and that's now going to pass my base. So if I call set base, it will automatically call my side one method for me. It'll pass it up the line. It really is not saving any code, but again, we don't know what other stuff is going on in the background maybe later on, but I want to be able to utilize those things, so I can utilize them because I don't have public variables right here. So the other piece that I'm going to need to have, since I don't have the public variables right here, is I'm going to want to have inside my parallelogram, I'm going to need to have a get side one and get side two as well. So I'm going to copy these guys. And we're going to go ahead and do a get, and this guy's going to be an int, and I don't need to take something in, I just need to return. So return the side one. Down here, this guy's going to be a get, let's make an int as well, and get side two. Don't need anything in my parameter list here. I don't need this S2 anymore. I just simply need to return side 2. Okay, so now I have these two methods up there. Actually, I should add my comments here. So there's get side 1 and get side 2, right? And so now I have those methods that I can utilize, which is going to give me the data out of these things if I need them, right? So if I need my base and my height, I can do the same deal again, right? I'm going to take these two real quick, and I can call them and say, so we have those right there. Okay, so we're going to change this to a get base, int, get base. Okay, I don't need that, and I'm just simply going to return super dot get side 1. And that will actually grab whatever's out of side 1 and the one above me. And I'm going to do right here, I'm going to change that to an int and change that to a get height, not a head height. There we go. And I'm going to simply return the super dot get side 2. Alright. And I'm just showing you. I'm not necessarily saying that this is the best way to go about doing this. Holy cow. Oh, I already had get base and get height in here. My bad. I didn't think I had those in there. I wasn't really paying attention. So let's just come down here and simply say return dot get or super dot get side 1. Return dot super dot get side 2. And those will actually take care of my get base and height now using that same side 1 and side 2 from above. And again, you're not required to use those variables. We could make up a room for base and height if you wanted to in here. All right, now my get perimeter. I already have a super for this one, so I'm just going to simply say return super dot get perimeter, which is the exact same thing as it was up there, right? So return super dot get perimeter, and that will actually get the perimeter out the one above, and just simply return it back. And then my area, I don't really have a base and height anymore, right? But I do have I can say return get side 1, or I'm sorry, we could just use the get base off of this one right here. I can simply say return get base from this method here times get height from the same method, and it'll go out and translate everything I need and grab the base and height out of the one above and actually do the math for me and multiply it out. And then the same deal here for my square root, I got errors now, right? Because I don't really have a base and a height variable. So I can just simply say get base and put up those parentheses right there, and I can do a get height and put up those parentheses right here. It'll actually go out and grab those values for me and then square them and then take the square root when I add them together and get my diagonals. And so now I got my diagonals actually working, and everything working for this rectangle class. I can even go out to this geometry class right now, and let's go ahead and instantiate, let's say rectangle R1 equals new rectangle. Okay, close parentheses, so that should by default set up as a 1 by 1, right? So let's go ahead and say sys out. We'll go ahead and just do our get area for this one. We'll say sys out R1 dot get area, and it will actually, it should output for us that is a 1 area of a 1. Right there it is, right there. And if I wanted to, I could actually pass in the values of 4, 5, and now my R1 dot get area should return back to me 20. There it is. So it's actually passing it through. I also have the ability to, remember we said that you can actually define the variable off the abstract class. So I could say parallelogram P1 equals, but I can't say equals a new parallelogram, but I can say equals a new rectangle. And I can pass in dimensions of 10 and 5, how about that? And so then I can come down here and I can sys out, let's just copy this guy, and do P1. Okay, and when I run that, you'll see that's area. So it's actually working, because P1 is a parallelogram and a rectangle is a type of parallelogram. So I can make a parallelogram variable point to a rectangle object, which is all part of that holy polymorphism thing a little bit here. So it knows which things to grab. And we'll do another example of that here in a second. So let's take this a little bit further now. Let's go into square, right? So a square is really just a rectangle. So I'm going to go ahead and say extends rectangle. All right. And when we set up our constructors in here, so I'm going to go ahead and say public square, and I'm going to do a default constructor on this, and we'll go ahead and do the same thing. We'll just go do that one right now, and then what is this guy simply going to do? It's just simply going to call the super constructor, which is the rectangle, and the rectangle is just going to call the super constructor, which is the parallelogram, and set it to 1 by 1, right? So that is the end of the default constructor, or actually it's usually called no arguments constructor. All right, and then I'm going to do the same thing here. I'm going to do, let's copy this. All right, and I'm going to pass in, let's say, int s, right? Because a square only needs one dimension passed in, a side. And remember, square, they're the same unit, right? So I'm just going to call the super constructor s comma s, and that will actually pass in my side to my rectangle and set it all the way up through the parallelogram one. So this guy is square. Let's see, int, because I'm only taking in one parameter there, and it's going to pass it in there twice, and it's actually going to create that for me. And we'll just go ahead. I'm not going to define all the different pieces out here. So I want to go ahead and let's just deal with things like the area and the perimeter and so forth like that, right? So I can go ahead and say let's do public. Public int get perimeter. Parentheses there, and we're just simply going to return super dot get perimeter. All right, and that will actually get our perimeter for us. And let's do a public int get area, and we're going to run our return our super actually go out and get the area. And what the heck, let's do our diagonals too. Let's do public, let's see, it's going to be a double, get diagonals, right? And fortunately for us, and notice we don't have the get diagonals is different for a parallelogram. This only really works for rectangles and squares because the diagonals on rectangles are always congruent to each other. So I can only return one value here. I'd have to do maybe an array if I want to do it for a regular parallelogram. So I'm going to go ahead and say return, and we're going to say super dot get diagonals. All right, there we go, and we now have all those in there. There's no errors. We extended it, and now I can come over here to geometry, and I can also do a square if I want here. Square S1 equals new square. And let's go ahead and set the dimension of that to 5. Okay. And I'm going to go ahead and come down here and we'll go ahead and do S1 dot get area, and just to show that it's actually working, we'll do our perimeter and our diagonals. Alright, so now when I run this, remember we set our rectangle to 4 by 5, so 20. We set our other rectangle to 10 by 5, so 50, which we did off the parallelogram. And then we set our square to a one dimension of 5, which made it an area of 25, which also is 4 sides of 5, which is a 20 perimeter. And then our diagonal is really just, what, 5 radical 2, all right, which would be 7.07. It's getting our diagonals for the square. We can also, if we wanted to, do we could set up an array list, right? So I can do array list, and then inside of here, I'm going to set it up as a parallelogram. Okay. Equals new array list. Sorry about that. Array list. We'll call it P list, right, for parallelogram list, equals new array list of parallelograms. And we can, after that, we're going to go ahead and just do it in close parentheses right there, and instantiate it to default size right there. And what do I have an error? Oh, oh yeah, I'm being a bonehead. I forgot to import. I'll just import Java util star. Just pulling everything, which will pull our list for us here. All right, so that solves that problem down there. Right now, I can go ahead down here and say plist dot add, and I'm going to go ahead and say square, and we'll do 7. That's up there. And let's go ahead and do another. Let's see what I can goof up here. Oh, new square. Sorry, new square. All right, and oh goodness, I'm such a bonehead. I didn't even realize it didn't have that capitalized right there. All right, so that should resolve that, right? So here we go. I created an array list of parallelograms, and it's set equal to a new array list of parallelograms. And right now I'm going to simply add in position 1 a square with a dimension of 7. All right, let's go ahead and say plist dot add, and we'll say new rectangle. And we'll go ahead and do 4, 5. All right, let's do 4, 9. All right, and let's go ahead and let's do a plist. There we go. set that to a dimension of 3. And we got a... Alright, so there we go. We added our square. There we go. We'll just go with 3 items in our list right now. Alright, so I can go ahead and we can do like a for each command, right? So I can say for parentheses, and everything inside of here is a parallelogram, so I can say parallelogram. We'll call it P, and then we're going to say colon, colon P list. If I do the capital list. All right, so then that's going to go through, it's going to create a variable P of type parallelogram, and it's going to associate it to every object inside of P list. And then I can go ahead and drop in my brace there, and let's go ahead and just do a sys out of, I don't know, I keep hitting the wrong thing. Rookie here. There it is. And I'm going to simply sys out. Let's do p dot. How about get diagonals? All right. And so that's just simply going to show you how this polymorphism works. Yeah, I'll add the capital L up here. And let's see. Oh, okay. I can't use get diagonals because I'm using a parallelogram. If I would have done this as a rectangle, it would have been okay. I forgot. I didn't make get diagonals inside a parallelogram. I should have probably made that abstract, and that would have been okay. So we'll go ahead and just do get perimeter. All right, there we go. So that takes care of that. And again, this doesn't care. Polymorphism simply says it knows that when I'm on object number 1, that it's using a square, so it's going to use the get perimeter method from inside square. And it knows when I'm on object number 2 on my list, it knows I'm dealing with a rectangle, so it's going to run the get perimeter from a rectangle, and on the third one, it's going to run from a square. So when I go ahead and I run this, there's our original stuff, and there's our perimeter, right? So we have a square of 7, right, which is going to have a perimeter of 28, and I have a 4x9 rectangle, right, which is going to give us a perimeter of 26, and then our last one was a square with each side being 3, which is going to give us a perimeter of 12. So this is actually working out for us. All right, so now what you guys need to be doing now is we're going to start out with a simple assignment, then we're going to move to something a little more difficult. In here, you have, let's go to our chapter 12 on class hierarchies and interfaces. We're going to go back to the exercises, and I'm going to go ahead and go to exercise number 4 right here. It says define a class diploma and a subclass diploma with honors, so that the statements down below will work. So like, in other words, you're going to put this in your main code, like, so make a main code called graduation or something like that, and drop this code in your main code, and then have diploma and diploma with honors, which extends diploma, and then set up in such a way that this is what's going to output, as long as you've got these defined right. This is really, really simple to build this. It's a pretty short program. All right, so that is what I'm going to have you guys do next, and then from there we're going to get a little bit more complicated. All right, I'll talk to you later.